So still no one is there in the lab, so let us wait for a few more minutes. Okay, fine. So we can start the lab now. So in the previous lab, we had discussed how to use this a priori algorithm. That is, we are having a data set, and from the data set, how you can find out largest frequent atom set, and all that we have discussed in the previous lab. And now in this lab, we're going to discuss that how you can find out association rules from those frequent atom sets. So these two are connected, right? So if you want to find out association rules, then you should have frequent atom sets, right? So in today's lab, we're going to discuss how you can find out association rules and different fundamentals based on this. Fine. So let us have some brief about the previous lab, and then we'll start this association rules and all. Okay, so from PPT, we have gone through different steps to use a priori, and we found candidate item set, frequent item set, largest candidate item sets, and largest frequent item set that we had done in the previous lab. Now, next step after this. So in exam, two kind of question can be there. First, find out frequent item sets or largest frequent item set or candidate item set or largest candidate item set. Second, find association rules. If they're asking you to find out association rules, then also you need to find out largest frequent item sets. Fine. So you need to read the question carefully, whether it is only for frequent item sets or for rules. Fine. So now we will discuss next practical, sixth one, that is association rules. Welcome, Uttam. Let me open the PPT also, just a minute. Okay, I hope it's visible. Okay, so what is the meaning of this rule? Here you are having beer diaper. In this rule, you are having beer on left hand side, diaper on right hand side. And into bracket, you are having two percentages, 60%, 100%. First percentage, if it is not mentioned, that you need to assume that first percentage represents support. Second percent represents confidence. So here you are having support of 60% and confidence of 100%. Now this is a rule. And what is the meaning of this rule? Beer given a diaper, that whenever customer is purchasing beer, along with beer, customer is purchasing diaper, and you are associating these two items. You are trying to find out association between these two items. And support, you are having 60%. Confidence, you are having 100%. That means what? That in transaction table like this or like this, in transaction table, out of all the transaction, let us say you are having 100 transactions, then what is the meaning of support 60%? That means that beer, diaper, both are there in at least 60% of transactions. There is a meaning of support, 60%. Now what is confidence here? Confidence is 100%. What is it? Confidence is 100%. That means that whenever customer is purchasing beer, along with beer, always purchasing diaper. That means what? That along with beer, wherever in transaction table, wherever you are having beer, in the same transaction, you will be also having diaper. In transaction table, wherever you are having beer, you will always have diaper along with beer. That is the confidence. That means that whenever customer is purchasing beer, you are 100% sure that customer is also purchasing diaper. You are 100% confident that customer will also purchase diaper along with beer. Right? So let us say whenever customers are visiting the store, the customer who are purchasing beer, they will 100%, you are 100% confident that they will also purchase diaper. And based on this kind of association, you can arrange the sequence of different items, place, position of different items and all. Other rule, diaper given beer. So whichever customers are visiting the store for diaper, they are purchasing diaper. Along with diaper, you are 75% sure that along with diaper, they will also go with beer. So you can say that in whichever transaction diaper along with diaper, in 75% of transactions along with diaper, they are also going with beer. So we'll see this with one example so that you can get it more clearly. Just a minute. Let us try to understand this support confidence with one example. Okay, I hope my screen is visible to all. Okay, so just first of all, let us try to understand the concept of, let us say this is one transaction table and there is one item set, let us say beer and diaper. And how you can find out support for this item set? How you can find out support? So for that, total how many transactions are there? 5. Total 5 transactions are there. Out of those 5, in how many transactions beer, diaper both are appearing together? In transition 2, then 4 and 5. So 3 transitions. Convert into percentage. Convert this into percentage. 3 by 5. We'll be having 60%. Now, this is support. And if you want to find out confidence, then confidence will be for association rule. So we are trying to find out association between beer given diaper. Here, what is the meaning of this rule? Confidence for association rule. What is the meaning of this rule? This rule means that whenever customer is purchasing beer, along with beer, how much sure you are that customer will also go with diaper. And so here you need to consider the number of transactions where beer is items on left hand side. That means that total how many transactions are there with item set on left hand side. That means that how many transactions are there with item beer. How many transactions beer is there? 3 transactions. So in 3 transactions you are having beer. Now out of all those 3 transactions where you are having beer, in how many transactions you are also having diaper along with beer? All 3 transactions 3 times. So that means that 100%. What does it mean? Wherever you are having beer, you are also having diaper. Always, wherever you are finding out beer, along with beer, you will definitely have diaper. You are 100% sure that along with beer, diaper will be there. This is how you are going to find out confidence. Now, just let us flip this. Just flip the item in association rule. There will be no change in support. Let us write. Let us say diaper beer. For support, there will be no change. So total we are having 5 transactions. Out of 5, in how many transactions you are having diaper and beer both together? Both together. Total we are having 5 transactions. Out of 5, in how many transactions you are having diaper and beer both together? 3. Again 3 by 5, 60%. Support and confidence. We are just flipping the items. So diaper given beer. What does it mean? This rule means what? Whenever customer is purchasing item on left hand side, how much confident you are that customer will also purchase item on right hand side? That is, whenever customer is purchasing diaper, along with diaper, how much confident you are that customer will also purchase beer? And so in total, out of all this, in total, how many transactions you are having item on left hand side? Diaper. In how many transactions you are having diaper? 4 transactions. Now, wherever you are having diaper, out of all the transactions, wherever you are having diaper, along with diaper, in how many transactions you are having beer also? 3. And so 3 by 4, that is 5%. That means that you are 75% confident that whenever customer is purchasing diaper, along with diaper, he or she will also go with beer. And so we have just changed the position. We have put what we have done. We have just changed the position of this rule, and as you can see that confidence for both the rules are different, because item on left hand side is changing and item on right hand side is also changing. and the meaning is also changing. Here, this means that when our customer is purchasing beer, you are 100% confident that they will also go with diaper. And here, whichever customer are purchasing diaper along with diaper, you are 75% confident that they will also purchase beer. In other words, along with beer, in the transactions wherever you are having beer, again repeating, in the transactions wherever you are having beer, in those transactions which are having beer, you are also having diaper in all those transactions wherever you are having beer. Meaning of this, in other words, in whichever transactions you are having diaper, out of those transactions which are having diaper, you are having 75% transactions where you are having beer. Okay, so that is how you can find out support and confidence. Okay, so candidate generation that we already discussed, that how can generate combination of two, that is CS C1, C2, C3, that is this combination of candidate. Association rule, confidence. What is confidence? Confidence is support count A union B divided by support count of A, that we already discussed, that let us say in the transactions wherever you are having beer, there is support count of A. Out of those transactions, in how many transactions you are having beer and diaper both, there is support count of A union B. And so that we also discussed. Now, here the same thing is given with one example. Now, for example, if whenever you want to find out association rule, you should have frequent item set first. This is the first of all, this is the frequent item that you are getting from this table by applying that a priori algorithm. And after this, you need to find out subset of that item set, and then from that you can find out these rules. So how to find out rule, that we'll discuss. Now just understand this confidence that we are getting. So this is a transaction table. Now observe this table. Here you are having I1, I2 both, given I5 only. That means what? Wherever you are having, or whenever customer is purchasing item I1, I2 both together, how much confident you are that customer will also go with item I5? And so in total, how many transactions you are having I1 and I2 both? In total, how many transactions you are having I1, I2 both? 4 transactions, T100, 400, 800 and 900. 4. Now out of those 4, in how many transactions you are having I5 also along with I1, I2? T100 and T800. 450%. That means that wherever you are having I1, I2, in 50% of transaction you are having I5 also along with I1, I2. You are 50% sure that along with I1, I2, customer will also purchase I5. Now just observe this thing, this rule. In how many transactions you are having I1, I5 both together? 100 and 800. Out of this 100, 800, in how many transactions along with I1, I5 you are also having I2? Along with I1, I5, I2. 2, T100 and 800. So out of 2, that is 100%. So that means that whenever you are having I1, I5 in any transaction, you will definitely have I2 also in that transaction. You are 100% confident that along with I1, I5, customer will also purchase I2. Right? That is the kind of meaning of this. This is how you can find out this confidence. And there is a concept of minimum confidence to find out strong rules. Fine. So first of all, let us try to find out the rules, and then we will understand the concept of strong rules and all. Fine. So again, repeating this part, that whenever you want to find out association rules, it is based on largest frequent item sets. Fine. So first you need to find out largest frequent item set, and then you need to find out. So after that, we have discussed in previous lab that how can find out largest frequent item set. Right. So this is connected. Right. So let us try to find out association rules for this largest frequent item set. How to find out this BC, largest frequent item set, that we already discussed in the previous lab. So we'll continue with this. After finding out largest frequent item set, how to find out association rules. So if in exam they are giving you that find largest frequent item sets, then you need to find out only up to, you need to perform the, you need to only apply a priori algorithm. You need to find out association rules. If they are asked to find association rules, then you need to find out all possible rules. If they are asked to find strong association rules, then you need to use the concept of minimum support and minimum confidence. This minimum confidence is same as minimum support. That means that kind of percentage will be given. That means that we want to consider only those rules which are having minimum confidence, 70%, 60%, like that. And so we'll use this strong rules. And so that is based on, let us consider this. So for this, you need to find out step. First of all, you need to find out largest frequent item set. We are having BCE. And so if you are having multiple largest frequent item set, let us say more than 2 or like 2, 3, 4, 5, then for each largest frequent item set, you need to find out rules. Currently, we are having only one largest frequent item set. And so we'll find out the rules based on this. So for this, step number 1, right now we are discussing to find out association rules. And how it is possible, it is based on largest frequent item set. And that we already discussed previously. So if they are in exam, they are giving you a table, minimum support, minimum confidence, then you need to first find out largest frequent item set, and then from largest frequent item set you need to find out rules. Here's step number 1. You need to find out subset of largest frequent item set. Here you are having subset of this except null. So subset can be B, subset can be C, subset can be E, can be BC, can be C, can be E. These are the subsets except null. Fine. So now based on this subset, you need to find out the rules. How it is possible? Find out, that's finding combination rules from subset. How it is possible? So first, you need to write down combination of one on left, combination of one on right. So if you are writing B, combination of only one, you need to write down the subset which is having one item except the item on left hand side. Let us say C. Then other item set is second one, C. So on right hand side you will be having item set except C. It can be E, it can be E also. Fine. So for example, E, for example. And here along with E, you can have E also. Here C is there. You can have B also. Then here, let us say E. On right hand side, you can have B. On right hand side, you can have C also. And so this is combination of one on left, combination of one on right. Now combination of one on left, combination of two on right. So on left B. Now on right hand side, you need to choose subset where you are not having item on left. So out of all this subset of size 2, in which item set you are not having B, C. So on right you will be having C. Then let us say C. On right hand side you need to choose such a subset where you are not having C inside that. Let us B out of those three. Then on left hand side E. Out of this, in which item set you are not having E, B, C. Now, is there any possible other combination of left on one, right on two, right side two? No. So just reverse this thing. Two on left and one on right. Okay, just reversing the above thing. And BE, then C here, then BC, then E here. And so now combination of two on left, combination of two on right. If you write down, let's say BC, in item on right hand side, you should not have the items of left hand side. So as you can see that in all three, either you can have B or C. Not possible. This is not possible now. And so you need to stop there. And now next step is to find out support and confidence for these rules. To find out support and confidence for all these rules. And so how it is possible? So first of all, in this table, total how many transitions are there? 4 transitions. It will be helpful to find out support. Fine. So out of 4 transitions, if you want to find out support, then you need to consider all the transitions. That's why it is divided by 4 for all the rules. Confidence, the scenario will be different. So let us try to find out the support first and then we'll go with the confidence. So support for BC. Out of 4 transactions, in how many transactions you are having BC both together? Just observe this table. 2, 20 and 30. Right, so 2, by 4, that is 50%. Now BE, out of 4 transaction, in how many transactions you are having BE both together? T 20, 30, 40. You will be having 66.66%. And calculate that also. Sorry, it will be 75%. Now, in how many transactions you are both together? CB both 2 times 20, 30. Again, you are having 50% of support here. Then, in how many transactions you are having CE together? 2 times 20, 30. 50% of support. EB together 3 times, so 5% support. EC together 2 times, 50% support. Now, out of 4, in how many transitions you are having B together? BCE together. BCE 2 times, 50% support. Again BCE together 2, 50%. Again BCE together. In all rest, you will be having 50% of support. So here what we have done, we have considered all the transactions, and out of all, in how many transactions both items are, or all 3 items are there, or the items inside rule is there. And so here we are considering the transactions. Now to find out confidence. If you want to find out confidence for this rule, B given C, for this you need to consider only those transactions where you are having item on left hand side. So out of this 4, in how many transactions you are having B? B is there in 3 transactions, 20, 30, 40. You are having 3 transactions where you are having item on left hand side, that is B. And out of all those transactions having B, how many times you are also having C with along with B? C along with B. That will be 66.66%. Again, you are having 3 transactions wherever you are having B, along with B, E. 3, all 3. So you can say that 100% confidence. Now, in how many transactions you are having C? 3. And out of all those 3, you are in how many transactions you are having B also along with C? Along with C, B. 2. That is 66.66%. Again, 3 transactions, out of those 3 where you are having C, along with C, how many times you are having E also? 2 times. 6.66%. Now, in how many transactions you are having E? 3. Out of those 3, how many transactions you are having B also along with E? Along with E, B. 3. Yes. So you are having 100% confidence for that rule. And out of those three, wherever you are having E, how many times you are also having C along with E? With E, C. 2 times. So 66.66%. Now other rules. Now in how many transactions you are having B? 3 times. Out of those 3 transactions, along with B, let us say here we are having 20, 30, 40. 3 transactions wherever you are having, we are having B. Along with B, CE together. Along with B, CE together. 2 times 20 and 30. C together. So 2 times, and we will be having 66.66% of confidence for that rule. Now C is there in 1, 2, 3 transactions. Along with C, B also. Along with C, B 2 times 20, 30. Again 66.66%. Now E, we are having 1, 2, 3 transactions. Out of those 3, BC also. 2 times 20, 30. And now CE, C together. In how many transactions you are having CE both together? 20, 30. So 2 transactions. Out of those 2 transactions, wherever you are having C both together, along with CE, you are having B. How many transactions? 20, 30. 2 transactions. Exactly. So you will be having 100% of confidence for this. Now BE. In how many transactions you are having B together? 3 transactions. Out of those 3, C along with B, C. 2 transactions. 2 by 3, you are having 66.66% of confidence. And BC is there in 2 transactions. Out of those 2, in how many transactions you are also having E along with BCE? 2 transactions. You will be having 100% confidence. And so what we have done, we have find out the rules along with support and confidence. Now the concept of strong association rules. And in exam, they will be given 2 things: minimum support and minimum confidence. So here in this example, minimum support is 2. Convert it into percentage. Convert this 2 into percentage. 50% that we had discussed in the previous lab. 50%. Okay, so this is 50%. That means what? Support count 2. Again, repeating this part. What is support count? Support count is nothing but count or number of transactions that we want to consider for our analysis. There is 2. And total we are having 4 transactions. Count support is 2. Just compare these 2 things. Just compare total number of transactions and okay, total we are having 4 transactions. So convert into percentage. So if any item is present in all the transactions, that means what? It is having 100% support. Then if it is 2 transactions, that it will have 50% of support. So here you are having 50% of minimum support. And just assume that you are having minimum confidence is equal to 70%. It will be given in exam. So if you are having any rule whichever we found, out of all these rules, whichever rules are fulfilling both the criteria, please note down this thing. The rules which are fulfilling both the criterias, they will be considered as strong rules. Rest will be considered as weak rules. And so which rules are fulfilling criteria? Is this fulfilling? Is it having minimum support, minimum confidence? Okay. Minimum support is 50%. Is it having 50% or greater support? Is it having 50% or greater support? Yes. Minimum confidence is 70%. Is it having support greater or equal to 70%? No. So we cannot consider this as strong rule. Why? Because it is not fulfilling minimum support and it is and minimum support and confidence both. Now, second rule, is it having or is it fulfilling minimum support criteria? Greater than or equal to 50%. Is it fulfilling minimum confidence criteria? Yes, it is having 100% confidence. Minimum confidence is 70%. So it is fulfilling. So we can consider this as a strong rule. Next, is it fulfilling minimum support criteria? Minimum support criteria. Yes. Minimum confidence criteria. Skip. It is weak rule. Is this? No. Skip it. It is weak rule. Is it strong rule? Yes. Is it strong rule? No. Weak rule. Are they having all the fulfilling criteria? No. Skip it. Is it fulfilling minimum support, minimum confidence criteria? Yes. It is strong rule. Is it strong rule? No. Is it strong rule? Yes. These are the strong rules. Why? Because they are fulfilling minimum support, minimum confidence both. Now, if I just slightly change one thing. Now, just change minimum support criteria from 50 to 70. And out of this, which will be discarded? Yes, last two, because it will not fulfill minimum support criteria. But for this, it is fulfilling. Right? So these are the strong rules. Why? Because it's fulfilling our minimum support and minimum confidence, both the criteria. Right? These are the strong rules. So in exam, they can be asked, they are asking to find association rules and need to write down the rules. If they are asking to find out strong rules, then apply the conditions of strong rule, weak rule, minimum confidence, minimum support. If they are asking to only find out association rules, then you need to find out all possible rules. If they are asking to find out strong rules, then apply minimum support, minimum confidence. If this is not given in exam, then you can assume also. If they are asking to find out strong rules, but they have not given minimum confidence or support or both, then you can assume it. Now, here we are having only one largest frequent item set. If you are having one more largest item set, then again for that item set, you need to find out subset, rules, strong rules, and weak rules. Are you clear about this, all of you? How to find out strong rules? About this, clear up to this? And so again repeating this thing that whenever you are asked to find out association rules, first you need to find out largest frequent item set. Then based on largest frequent item set, you need to find out this rule. Right, so this is based on largest frequent item set. So if you are asked to find out association rules, then you need to find out largest frequent item set first. This kind of table will be given. Minimum support, minimum confidence will be given, and you will be asked to find out association rules or strong association rules. Then you need to find out largest frequent item set first. Then you can find out rules and strong rules and all. I hope up to this all of you clear. Anybody any doubt, any question? Uttam, Shivam, Jansi, Vaibhav, Darshan, Harsh, Jinal. Anybody any doubt up to this? Anyone in doubt? Okay, fine. So I hope that there is no query. Fine. So in today's lab, we had discussed this demonstration of finding association rules and concept of minimum confidence, and based on minimum confidence, minimum support, how to find out strong rules. Fine. So we also discussed that how you can find out different association rules irrespective of confidence or minimum confidence. Fine. So all we have find out all possible association rules. We discuss all these things in today's lab. So practical 6 is completed, and in that you can mention that example that we have discussed of that table with 4 transitions and BCE largest frequent item set. Fine. So in this practical, you can mention that example demonstration. You can give the demonstration stepwise. You can also explain the concept of support, minimum support in practical 5, and concept of minimum support, minimum confidence both in 6. Fine. So I hope that there is no query. Fine. So we had completed 6 practical today. In next practical, next lab, we will use Veka and we'll try to find out and apply a prior algorithm. We'll try to find out frequent item set and rules. So taking the attendance now, just a minute. Okay, Harsh, and thank you, Darshan. Thank you, and Vancy.
Yes, sir.
And Jinal,
Present, sir. Present, sir.
okay. Just a minute. Sorry, I was disconnected. Thank you, Jinal. Then Uttam.
Yes, sir.
Uttam.
Yes, sir.
Into the
Yes, sir.
Vaibhav.
Vaibhav 1 4.
Yes,
Thank
sir.
you, Shivam.
Shivam.
Okay. Apart from this, anybody else? Anybody left? Fine. So we completed 6 practicals. I will upload the task, and you need to upload that in Google Classroom. Mid-1 syllabus is already discussed, Shivam. It is unit 1 and 4.